Christina, thank you so much for having me on UX Design Talk. This is an honor. I'm honored to be here. It's great to see you after like such a long break. I'm glad to see you doing stuff like this. This is awesome. And thanks for having me on it. And thanks everybody for attending. I appreciate it. Uh, I've like given this talk several times in the past, and the topic of the brain has always been interesting to me because of its intricacies and how it really does at the end of the day affect like what we do as designers stems through how people interact with the world, and how people interact with the world is all based on their brain. So I quickly learned that in school and fell in love with the topic in grad school. But me out in the world, I'm like a mix between product and design and research. So I do a lot of like agile UX, continuous discovery type work, and work to kind of orchestrate experiences. And I hope there's not a lag here. Christina, is there any type of like lag? Cool. So we're going to try this. First thing we're going to do, you may have seen this video before. First thing we're going to do is we're going to see how well you can multitask, each of you. I want you all to count the team in white's passes. How many passes did the team in white make? And you can count silently. At the end, I'm going to ask you what the number was. There may have been a lag there. Who got any number? What number would you say?
Morgan, I think we need to share your deck again.
The deck. Apologies.
Oh, we have numbers coming in the chat. We have 5,
good.
8, 16, 6, 7, 6, maybe a dozen, 12, 11, 7. And then somebody said something that I don't want to say because it might be a spoiler, but I see 13, 14, and 6. So
yeah. And you may have seen it because there was a lag. However, 11 is pretty close. The answer was 13. So I'll count it if you had 12. I'll count it if you had 11. But there's a kicker to this. Right there. Did anybody see the moonwalking bear? Even if it was a lag. Yeah. I'll send this video in the link in the chat. You all watch it on your screen without a lag. And I want you to really pay attention to the number of passes that the team in white makes. Because if you really pay attention to that and you get the number correct, you won't see the bear. You won't see the bear at all. As crazy as that sounds, it's a good example. I think you'll see it as soon as you see it on your own computer. That sensing is not the same as perceiving in the world. The things that you would see on screen. Yeah, exactly. Yeah, you could even know that the thing is going to be there. But if you're not perceiving it, your brain's not picking it up. Your brain's not interpreting it. Sensation deals with what you feel, what you smell, what you see. And perception deals with how the signals in your brain interpret those signals coming in from the world. And just because you see something doesn't mean that you perceive it. And it certainly doesn't mean that you're going to understand it. And it definitely doesn't mean that you're going to remember it. And you can clearly see where this is going as a UX conversation. Just because something is there on the page doesn't mean that your users are going to successfully use it, let alone notice it. Because there's actually a hierarchy going on in the components of your brain. And the first level of that is taking in the senses. And the second level of that is perceiving. And then from there is memory and attention, comprehension, learning. All of the things that you may have heard before about cognitive load, user friendliness, frustration, they all stem from, does the user perceive it? So we're going to focus on that. We're going to focus on what's called wayfinding, which is how to find things, how users find things on their own, color and contrast, and making sense of the world, how the brain makes sense of the world. I'm just going to stop here. Is the audio good? Is the video good? Everything good? All right, cool. You may have heard wayfinding as a term before, and it's a term that is super useful for UX design. And it's a strategy and an understanding of how users find things on their own. Well-known fact, UX in academia started as information science, library science. The science of how people find things was embedded in that. Search and filter behavior was born from information science. And wayfinding was the study of how people find information on their own. You can apply that to lots of things. Here's a video example of how somebody looks for something on the web. Couple things to note. The circles are your gaze. This is called an eye tracker. And so the larger the circle, the longer this person is looking at this thing. And the line is the direction of the eye movement. And you can see where their eye is going and how long they're looking at things. The green is their cursor. So sorry, I keep doing that. Pay attention to the fact that the cursor is not where the eyes are going. Right? You can clearly see that. Just because someone's cursor is somewhere doesn't mean they're looking there. Secondly, you can see that this person is jumping around on the page after they get through this section. They don't hit everything on the page at all. They're obviously looking for something. This is the person wayfinding on the web. When you build an experience, you need to design for them to be able to find things on their own. It's always based on some type of goal. This person has some type of goal in mind. Apparently, the goal of this person is to watch this video about this octopus. This is what they were looking for, and they found it. And in the video, you were, if you watch it on no lag, your instructions were to count the passes from the team in white. And your brain doesn't pay attention to black or gray or other types of colors in the moment. Even though it's on the page, it's always there. I'm sure you all have done Where's Waldo before. Was what they were looking for? Hold on 1 second. Let me go back to the chat here. Was that what they were looking for, or did it just catch their interest? Yeah. Well, we don't know. It could have been. It could have been either. Let's take a look at Waldo. The goal of Waldo is to find Waldo. If you're looking at a book for Where's Waldo, you're going to look for the things that you know about Waldo. Your brain's going to look through all of its little repertoire and see what it remembers Waldo as. And it looks for clues based on the goal. It looks for, in this picture, people that have red stripes, glasses, stylish beanies, lanky bodies, and your brain doesn't pay attention to the fish or the snake. It's taking it in, though. Your eyes are sensing it. And then what's happening from there? Your brain's filtering whether that's relevant. Is that relevant to the goal? Is that fish Waldo? No. All right, ignore it, move on. If a user spotted that fish, thought it was Waldo, my grad school professor would say that users don't make errors, they try to solve problems. If someone is going down the path you don't intend, or they make a mistake in identifying something, is it on them? Or is it on you not understanding their goals? Take a look at this picture. What's the shortest distance on a triangle? The path that the users have drawn in the grass. Why would they be cutting across the lawn? To save time, maybe. So if a designer knows the goals of people in the area trying to walk down that path, they would account for that use case that users would do naturally because that's what they do. Their goal is to go quick, to save time, to get to point A and B. And so they're just trying to solve a problem. To the landscaper, you just destroyed their lawn, but they didn't make an error. They were just trying to solve problems. Y'all ever seen this type of door before in the world? You may have some in your neighborhood. Does it look like it could be pushed or pulled? On the other side, it looks like it could be pulled or pushed. And on the outside, it looks like it could be pulled or pushed. I would push it. Does that make me stupid if the sign says pull? Well, does it look like it can be pushed or does it look like it can be pulled? I think it looks like it should be pushed. I think it's on the designer. It's not on me. I'm just trying to solve the problem of opening the door, and I don't understand how to use it because it's not giving the right signals off. The other side doesn't really give me any visual clue either. So I'm standing there at the door. What do I do? What do I do? Don't even notice the sign, and then I push it. Why does that message exist? What if you designed the door handle like that? What if you designed the door handle like this? What if you designed a door handle like this? Yeah, Norman doors. They're everywhere. But the point here being the visual signal is going to be stronger than the sign. A well-designed interface is going to help people wayfind by giving off the right proper visual signals. The door handle is going to look like you can pull it. And that's what's going to help people wayfind. There's actually several things that you can do to help people wayfind. You got to answer these questions. Take a look at the door example. Will they open the door? Well, is their goal to get in the building? Maybe. Do they notice the door? Maybe. Do they recognize it as a door? Maybe. Have they had experience with that type of door before? Maybe. Does the door look like it can be opened? Does it look like it can be pushed or pulled? How does it look like it could be opened? But if it was circular, does the person understand how to open? Well, that really depends on a lot of things. That depends on the visual signal. It depends on their experience with it. It depends on maybe the poorly designed messages on the door saying how you should open it in all the different ways. And at the end of the day, you got to measure whether they can do it without error. Can they do it without any type of mistake? This is all UX, all of it. Research, the study of perception, and how you can affect perception, how you can get people to notice things, their mental model and their expectations, the relationship between the objects and them, and the visual signals they give off, and how people find things on their own. They're looking for clues. All of this is things that you can control. Everything we do as humans relates to a goal. Every activity. Counting the number of balls that the team is passing or finding the octopus article, whatever it is, doesn't matter. The brain can only hold so much at one time. So your brain's going to not pay attention to the things that don't relate to the goal. This is why users don't notice the things that you design. At the end of the day, even crazy things are not going to be noticed if it's not their goal. So we as designers should be designing for things that are self-evident. Things that come across as intuitive or things that just make sense. They give off the proper visual signals. They help you learn how to use the system yourself. You just kind of figure it out. The pieces look like they can fit together. You know, they give off the signal that they go together. Those types of things can help people like reduce learning curve, reduce the complexity of learning something over time. If you do your research, you have to then prioritize kind of understanding the current ecosystem that users live in, their motivations, their pain points. You also need to understand what you would prioritize from that in the solutions. And if you visually help them follow the breadcrumbs, you can help them scan the page, look for clues, find what they're looking for quickly. The entire goal of information architecture and information hierarchy is for people to be able to look for clues on their own, quickly scan the page. And if you can build things that guide people to action, you could do it visually. Do it visually through different types of sizes of headers and visual elements on the page that I'll show you in a little bit. It's also really important to give off the proper visual signal. If you make the door look like it can be pushed, your users are going to try to push it. So if you don't give off the right signal, they're not going to understand how to properly interact with things. The other huge component is to not make them rely on their own memory. If you give them a little bit at a time, You give them the option to know more if they want to. You give them very clear instructions. What do I need to do? What decision do we need to make as a user? And give them the visual feedback. Help them make the decision and then help them understand that the decision has been made. And all of that is going to help them wayfind because they have to rely less on their memory and they can focus their brain on finding what they need. Let's look at some illusions. Is the left eye the same color as the right eye? Yes or no? You could just put it in the chat. How about now? How's it different? Some are saying same, some are saying different. How about now? It looks like it has a little bit of a blue tinge with the red around it. And without it, it looks the same color. And it's the same exact picture. It's just red is added around the iris of the eye. And then a darker shade of red. And it seems to get a little bit more blue, but it's not. It's just the same color every time. Take a look at this one. Is the A square or the B square darker? Or well, what's the difference? Are they darker? Are they the same color? Is one lighter than the other? Which one is lighter than the other? Put it in the chat and see if you can. I'm curious to know your answer on this. Here's A. It's an illusion. It is a trick. Here's B. What's happening here? Even in the context of the picture, and then you isolate the A and the B, I can still see the board looks that the B is a lighter square. What's going on in the brain? From an evolutionary standpoint, we humans, Homo sapiens, have adjusted to detect more contrast than color in your eye. You're actually way more sensitive to contrast and motion than to color. We just saw very clearly two illusions where you got tricked. Your brain tricked you. What is color anyway? That kind of sheds light on what is the actual real color of that. If your brain's picking up some completely different color, which one's the real one? Is it the one that your brain's perceiving, or is it the one that is giving off the light on the screen? Color is an illusion. It's a combination of light and reflection and human interpretation of what the color means, maybe cultural, and visual perception. The rods and cones in your eyes. The eye has many less receptors for color than for contrast. If you have ever walked around in the dark, you'll probably be able to notice things that are like moving really easily. And that's because motion and contrast has been honed in our brains, honestly, our eye to brain system. And to add to that, colors are very openly interpreted in different cultures. So if we in Western culture use red to indicate stop or don't do this, it means something completely different in different cultures. And so the mentality of using color to get people to notice things and to get people to interpret things is very chaotic, can be very variant because of these. Not to mention colorblind. So if you sense different things and you're picking up different shades of color, you are going to rely way more on contrast than color. So you as a UX designer can use the same distinguishing effects, contrast over color and motion on the screen. Use those in tandem with each other. You can get people to notice things a lot more easily. But it has to be their goal. Now we're going to talk about some patterns. What is this a picture of? Yeah. Yeah, definitely. It is a bunch of blobs, but it looks like a Dalmatian. Your eye picks it up. Just like if your eye senses animals in the sky, in the clouds. Your brain doesn't like the chaos. It doesn't like looking at this and not making sense of what's going on here. So it picks something from your memory that you know. If you've seen a Dalmatian before and you've had experiences with Dalmatians before, you're going to notice a Dalmatian here if your brain picks up the pattern of the dog that looks like the spots, that looks like a Dalmatian that you've seen before. For those of you who didn't see a Dalmatian in particular, or like didn't see a dog, think about if someone has never seen a Dalmatian before, what would they see here? What would they see? Would they see a dog? Would they see a Dalmatian? They might see a cheetah, yeah. No, it kind of looks like a cheetah, for sure. Your brain has to have the experience to draw from, to draw that pattern. Looking at the thing on the bottom right, this looks like a candelabra, and it also looks like two faces. Your brain can kind of switch back and forth between the two. But you have to kind of be, your brain has to know what it is. If your brain has never seen that before, a candelabra, but you might notice it as something else, or the brain might notice it as a cup or something. Your patterns will take over everything in what you perceive. And your brain is going to rely on the memory and experience that you have in your own brain to rely on the patterns. And this is where common design patterns and mental models come in. You've probably heard that as a designer. Use common mental models. Well, this is why. Because if your brain senses the pattern, it knows automatically, it can draw automatically from how to do it, how to interact with it. And it notices the affordances and the signifiers, the visual signals that it's giving off. There are two terms that Don Norman had coined, I think. Affordances and signifiers. Affordances are our human relationship with objects. The cup, the essence of the cup, is to hold things. And it looks like it can be held, gives off a signal that it can be held because it looks like it's got a handle that fits my hand and it's round and it's cylindrical, gives off that visual signal. But my relationship with the cup is its affordances. The examples: a coffee cup can hold liquid, a ball can be kicked, a chair can be sat upon, a button can be pressed. The signifiers are the shapes of things. The ball is round because it gives out that signal, and it makes it really easy to roll it. It gives out that signal pretty loudly to roll it. A red glowing cigarette ash is a signifier that you should not touch it. Unless you don't know, maybe if you've never had experience with it and you pick it up and you burn yourself. A doorknob's round shape versus a doorknob's horizontal shape. If you want to design for making sense of the world and making sense of the patterns that people are going to notice and adhere to that, starting with the right signifiers and common mental models is the right way to go, so that your users will be able to intuitively understand the relationship between things. Another aspect, a really important aspect of UI design, is Gestalt. Gestalt is a form of psychology that shows how perception affects how we perceive the shapes of things and the visual space of things, how that affects our perception and how we perceive the relationship of objects. So Gestalt and understanding and applying Gestalt can help you identify things and help your users identify things, help them visual orient themselves, help them follow a flow, and help them understand the difference between this thing and that thing. Here's the first example. You traditionally would read this as "don't dead, open inside." But there's a clear line in the middle, I think right in the middle of it. And my brain now reads it as "don't open, dead inside." This is the continuity principle of Gestalt. Stop war, peace now. Stop peace, war now. Just the simple addition of the lines and the color helps you guide your eyes in a very different fashion, completely, and change the way that you're interpreting this. Grouping. Objects that are grouped together are going to be perceived as similar and related. There are two groups being presented here because there's more white space here and less white space around in between the shapes. And so my brain picks up this group A, group B, even though these are different colors. It's the proximity of them that makes them look like, and the grouping of them that makes them look like they're related. Similarity is similar to the grouping and the proximity. These are all going to be perceived as squares. And this one, because it's in with other squares, my brain picks up that it's a square. If it was looked at out of context and without other squares, it would probably be interpreted as a diamond. But I'm looking at it and thinking it's a square. It's just tilted because it's on the page with other squares. Same thing with the green and the striped one. They're still squares to me because they're similar to the other ones, but not in color, just in shape. They have different pattern, different color, but they're still squares to me because they have a similar shape. The emergence principle is the same principle that you saw with the Dalmatian. Your brain is going to fill in the patterns here, and it doesn't like the incomplete picture. It's chaos. So it makes it look like it's overlapping triangles in this picture because that makes your brain nice and happy and cozy because it's not chaos. But in reality, there are no triangles. It just looks like there are. The emergence principle is going to tell you that your brain is going to fill in the shapes if there is white space in between. So even if you don't actually have a line around the shape, your brain's going to fill in that line. Common region, I'll tell you that if you box things around a common region, you can use this to your advantage as a UXer by creating these regions of similar grouping, similar shape, and then spacing. If you have something further apart, it'll be perceived as not related to it. So you can use common region grouping and proximity very similarly to each other. In closing, all the designers in the world have all the power to control whether somebody sees or perceives or understands something. It all starts with all of the things that we talked about in the will they section. Will they do this? Will they X? Will they Y? Well, is their goal to do that? Do they notice it? Do they recognize it as that? Do they have experience with it? Does it look like it can be interacted with? And how? Does the person understand how to interact with it? And can they do it without error? If it's not their goal to do the thing that you're trying to get them to do, you might need to realign your research and go back to the drawing table. If they don't notice the thing, you can rely on Gestalt principles, common mental models, and other types of things to get them to potentially notice. Have the proper information hierarchy. Put it in there right in the moment that they need it. Do they recognize it as a thing? Are you using a common mental model? If you're not using a common mental model, it's okay. You should just rely on Gestalt principles and things that can aid in your perception, someone's perception of that thing. Do they have experience before with that? Goes back to the common design patterns. And if they can't do it without error, that's kind of a thing that stands on its own in terms of usability, user-friendliness. Will they be able to wayfind in the experience that you've designed? And above all, you can do all these things, but you still need to test all of them. Test with users and make sure that you're doing iterative validation on everything you're building, because it's one thing to design for the theory and then to validate it is a completely different thing with your target audiences. These are really good books. They cover a lot of the things that I talk about in this class, or talk, whatever. And in closing, I'll leave you with a quote. In a sense, when we look at the world, we're hallucinating all the time. And one could regard perception as the act of choosing the one hallucination that best fits all the incoming data. And with that, I'll leave the floor open for questions or comments.